Hello everyone, I'm Shishran, and today I'm going to talk about Snapchat animated bitwise operations tutor. This is from the course of computer system architecture. Well, coming to the topic, introduction to Snapchat animated bitwise operators. This presentation includes how Snapchat uses animated bitwise operations to enhance user experience, like the app Snapchat, which uses these animations to enhance the user experience, like how they contribute to the user experience of the app. Like these bitwise operations are fundamental of manipulating data, digital data. Using these operations, the digital data is manipulated, creating these animations in the app. Understanding these operations can help developers and enthusiasts improving the coding skills related to multimedia applications. So, if we learn this bitwise animations behind these animations in the app, we can improve our coding skills, and also uh, we can relate to the multimedia applications, and we also can understand how they work and how we should make them work. And coming to what are bitwise operations, bitwise operations are procedures that are directly manipulate individual bits within binary data. So these bitwise operations or operators, they directly manipulate data, like in the bits, like zero in the zeros and ones. These bitwise operators, they help manipulate the data to our desired form. The common operations in these bitwise operations include and or XOR, NOT not, left shift and right shift. Uh, this can be correlated to logic gates, which I have studied since 8th standard. These operations are essential for tasks such as image processing, encryption, and data compression. Uh, yeah, let's coming to importance of bitwise operators in Snapchat. Snapchat leverages bitwise operations to animate filters and effects smoothly in real time. They enable efficient data handling, reducing latency and improving performance on mobile devices. Understanding these operations can help creating more dynamic and interactive multimedia content. So how this contribute to the Snapchat app is, this the app Snapchat, it leverages these bitwise operations to animate the filters which run in the app, and also the effects uh, to correlate it to it smoothly in real time. So these bitwise operators, which maintain the flow of frequency between the animations and the uh, real time effects, they make it smooth, so there should be no input lag, or there should be no glitch. Like they both should run on the same equal time without any stuttering, etc. This bitwise operations help in that doing that. So they can do efficient data handling, they can reduce latency, and also can improve performance. Even on low spec devices, like uh, very low RAM storage, etc. This can handle due to these bitwise operations, uh, due to this efficient data handling and etc. These animations, etc., can work on the app easily. It also improves performances in these devices. um, there should be no too much RAM leverage for this particular task. Like understanding through understanding this, you can create more things like this to dynamic and interactive multimedia content. Um, well, coming to basic bitwise AND operation, AND operation. The AND operation compares two bits and returns one bit if only both bits are one. So how this works is, it checks the binary code first. Like uh, it compares two bits. Like there are two bits. We have two bits, which could be either zero or one. Uh, it returns one. Like it forwards one if the both bits are one. If not, it's closed. Like it doesn't forward anything. So if both bits are one, like in the probability of it being zero or one, if it is one two times, it returns one. It is used in masking or isolating specific bits of data. So how this works is like the zero and one, which when one is forwarded, the zero is masked, right, which it stays behind. So due to this logic, uh, by using this logic, we can mask and isolate specific bits within the data. For example, applying and with a mask can extract particular color channels in an image. So using this, we can extract color channels, like we can show colors on the screen by using this particular AND operation. Coming to basic bitwise OR operation, the basic OR operation compares two bits and returns one if either bit is one. So this in this how this works is, uh, compared to previous AND operation, in there the both bits should be one to return one, but here only one bit is needed. So either if one other one is zero or not, it will return one only. So if both are zeros, it will return nothing. So this works like that. It is useful in setting specific bits to one without alerting others. Oh yes. Uh, so it defaultly takes one if one is present in the previous two bits. So it can set specific bits to one due to the its speciality. In Snapchat, or can be used to combine multiple filters or effects dynamically. So it can smoothly combine both filters to create a new one. This is how this works. We'll coming to the next one. XOR operations and its uses. XOR compares two bit sentence one if only the bits are different. So how this works is also similar to the previous ones. In the previous ones, we saw that there's in the first one and there should be the both bits should be same. Or, same means one. The both bits should only be one. Then only get penny return. In the second one, either one of the two bits can be one. But in here, the both bits should be different. It means uh, either 0 or 1. Like I know one bit should be 0, one bit should be 1. Then only it can return 1. Only if the two bits are different. If one is 0 and one is 1, XOR it returns the 1. If not, it doesn't return nothing. It is commonly used in image encryption and toggling bits. Animated filters can use XOR to create reversible effects or flickering animations. The flickers we see on the app, like while using the filters, we can see the flickers, right? Like if it's not properly syncing to the face, etc., we can see the flickers. So, or we can say the animations which move, which move through the filters, like uh, the flickers which move. This particular XOR operation can help do that. Coming to the next, bitwise not operation, NOT. The NOT operation inverts all bits in a binary number. It's useful for creating native images or highlighting specific features. Snapchat may utilize NOT for special effects that require inversion and color manipulation. So this not operation inverts all bits, like it reverses. Inversion means rotating to the exact opposite. Inversion means, so this inverts all bits in a binary number. So it being utilized in Snapchat, how does that being works is it creates negative images. Like if you want to know what about negative is, it's the complete contrast opposite of a color. Like how black is for white, the negative image is the complete contrast opposite of a colorful image. So this not operation, because it inverts a bit, it also directly inverts the entire data in a binary number, creating a negative image through which some special features can be highlighted which may not be visible in a particular colorful image. So this Snapchat app may utilize not NOT for special effects that require color inversion or color manipulations. So this negative effect can be used in we can be it can be seen in many different places. Like some features should be to be highlighted, in some editing, etc. This NOT can be used to highlight the specific bit of the picture or the video, etc., to highlight it, or the in the filters to highlight the edges of the filter, etc. This NOT can be used to create a complete contrast opposite to the entire colorful filter that there is. uh, to have a border, or you want to create a particular edge of the filter, you can create a sharp edge. It can be seen, it can be noticed quite easily due to its contrast, uh, compared to the its entire shape or color. Well, coming to bit shifting operations, there are also two shift operations, the left shift and the right shift. So left shift and right shift move bits to left or the right, effectively multiplying or dividing the powers of two. These operations are fast and useful for scaling and adjusting data in the animations. Snapchat animations can use shifting to create smooth transitions or scaling effects. So these left and right shifts, they can either divide or multiply the bit with the powers of two. Like if it goes to left, it multiplies, or if go to right, it divides. So these operations are fast and useful for scaling and adjusting data. So due to this left and right shift operations, we can scale and adjust the data in the animations, like how the data uh, flows through it, and flows through how it works through it. Snapchat animals can use shifting to create smooth transitions, like uh, the filters which are not stationary. Due to this, it can create smooth transitions, like one flicker with the use of flickering and the shifting operations, it can entirely change the background. Okay, it can change the uh, sh- phase, etc., to create a scaling and transition effects. Yeah, coming to combining operations in for animation effects, multiple bitwise operations can be combined to generate complex animated filters. For example, masking with and toggling with XOR and shifting can produce dynamic visuals. Understanding how to combine these operations is key to optimizing Snapchat's animated effects. So these multiple bitwise operations which you all talked about, land, XOR, or not, and the shift operations, they all can be combined to create a different, very different variety of complex animated filters, which may be designed to whatever the developer desires or whatever the user decides to be. For example, first we talk about the A and D, which masks a particular zero, and toggling with XOR like the two opposites, and shifting like dividing or multiplying can produce dynamic like masking some and toggling some and shifting some by using all these operators, bitwise operators, which can produce a very stunning and enhanced image. Like, if we can properly utilize all these bitwise operations, we can create many much more filters for this natural animated effects. Well, coming to a practical example, creating a filter animation. The filter animation must start by masking certain color channels using A and D. And then XOR could toggle features to animate flickering effects. Shifting bits could be used to adjust the scale or position of overlay elements in the animation. So we take a colorful background, which may compose all the colors, and through using this AND bitwise operator, we may mask certain colors, like the colors which you do not, the colors which you do not like, and can shape it according to whatever the filter shape we want. And through the AND operator, we can completely mask it. After that, we can toggle the colors we want using the XOR operator, uh, which returns one if two the bits are completely opposite, and the shifting left and right shifting bits, which can divide and multiply the scaling, can be used to adjust the positions of the elements in the animation. Coming to benefits of mastering bitwise operations when Snapchat developers. Mastery of this operation allows for more efficient and creative filter development. Developers can optimize performance, leading to faster, smoother animations. It opens up possibility for innovative effects and more engaging user interactions. So, by mastering these operations, we can be more efficient in creating these filters, and developers can uh, do by doing this can also optimize performance, making it very smooth, fast, and easier to use. So it can open new possibilities for uh, new effects, like very different variety of effects, and also it can make user experience very engaging. Coming to the conclusion and resources, understanding Snapchat's bitwise operations enhances both technical skills and creative potential. Practice with real-world coding examples to solidify your knowledge. Additional resources include coding tutorials, official documentation, and community forums for ongoing learning. So, by using these resources, we can learn how to do this in real life. We can compare with the other examples to do this on our own to create these filters. Uh, so thank you for listening to the presentation.